Good day, everyone. Today, I'm going to discuss to you about standard form of an equation of a hyperbola. The most essential learning competencies that we will be tackling will be, first, define a hyperbola, and second, determine the standard form of the equation of a hyperbola. Here are the standard form of the equation of a hyperbola. Hyperbola can be oriented horizontally and vertically. If it is oriented horizontally, and center is at the origin, we have the formula x squared over a squared minus y squared over b squared equals 1. And if it is vertically, we have y squared over a squared minus x squared over b squared equals 1. If the center is at hk, we just simply write x minus h and y minus k. Let's now identify the parts of the hyperbola. This is a hyperbola oriented horizontally. Number one is what we call the center. Here is the center. And the center is located at the origin. The second one is vertices. Here are the vertices. And the third one is the foci. Here are the foci. So we can denote foci as f sub 1 and f sub 2, while vertices as v sub 1 and v sub 2. For center, we can denote that as c. As you can see, vertices and foci are aligned horizontally because the hyperbola is oriented horizontally. The next one is the asymptotes. As you can see, the asymptotes are lines, are those broken lines in the graph. And the last one is the endpoints of the conjugate axis. Here are the endpoints of the conjugate axis. You will be able to see a rectangle, and this rectangle is what they call auxiliary rectangle. Okay, now in this illustration, this is also a hyperbola oriented vertically. As you can see, vertices and foci are aligned vertically. Now, as you can see, we have here f sub 1, v sub 1, c, v sub 2, f sub 2, and then as you can see, vertices, we can get vertices by using the value of a. So, from the center to any vertices, we have a units. And then foci, we can get that using c. So, from center to foci, or any foci, we have c units. And then, to get the endpoints of the conjugate axis, we use b. So, from center to any endpoint of the conjugate axis, we have b. So, likewise, on ellipse, we're going to use the values of a, b, and c in hyperbola. Here are the patterns in finding parts of a hyperbola. We have center at the origin, center at hk, and the orientation, it can be horizontal or it can be vertical. Take note of the equation of the asymptotes. So we have the formula y equals positive negative b over ax if the orientation is horizontal and the center is at the origin. And if the orientation is vertical and the center is at the origin, we have y equals positive negative a over b x. Now let's have an example. But before that, let me remind you that in hyperbola, we use c squared equals a squared plus b squared. Unlike in ellipse, we use a squared equals b squared plus c squared. Because in hyperbola, c is the greatest distance or the largest distance of the three. Let's start identifying if the given standard form of the equation of a hyperbola is oriented vertically or horizontally. For instance, the example is x squared over 16 minus y squared over 9 equals 1. In order for us to know the orientation of the given standard form of the equation of a hyperbola, we're going to take a look on the first term. The first term is x squared over 16. Since x comes first before y, it implies that the orientation is horizontal. Another example will be y minus 3 quantity squared over 25 minus x minus 5 quantity squared over 36 equals 1. Since the first term is quantity y minus 3 quantity squared all over 25, and since y comes first before x, it implies that the orientation of the given standard form of the equation of a hyperbola is vertical. Let's try another example. For instance, the given is x minus 3 quantity squared over 38 minus y squared over 1 equals 1. As you can see, the x comes first before y. So it implies that the orientation is horizontal. Let's try an example. For instance, the given is x minus 3 quantity squared over 25 minus y minus 7 quantity squared over 144 is equal to 1. The first thing that we need to do is to get the value of a squared. The value of a squared is this one, 25. Why is it 25? Unlike in ellipse, tinitingnan natin kung ano yung pinakamalaking value ng denominator to find a squared. However, in hyperbola, kung ano yung naunang denominator that represents a squared at yung pangalawang denominator that represents b squared. So b squared is equal to 144. We need to get the square root of both sides to get the value of a, and a is equal to 5. Likewise, to get the value of b, we need to get the square root of both sides. So therefore, b is equal to 12. To find the value of c, we use c squared equals a squared plus b squared. By substituting all the values, we have 25 plus 144. So therefore, c squared is equal to 169. To get the value of c, we need to get the square root of both sides. So c is equal to 13. Therefore, the values of a, b, and c are 5, 12, and 13 consecutively. Let's try another example. For instance, your given is x plus 7 quantity squared over 49 minus y minus 1 quantity squared over 576 is equal to 1. The first thing that you're going to do is to find the value of a squared, and a squared is equal to 49. Why is it 49? Again, kung ano yung unang denominator that represents a squared. At yung pangalawang denominator that represents b squared. So b squared is equal to 576. Squaring both sides, we can get the value of a, and a is equal to 7. Likewise, we need to get the square root of both sides to get the value of b, and b is equal to 24. Now, to find the value of c, we need to use the formula c squared equals a squared plus b squared. Substituting all the values, we can have, instead of writing a squared, we're going to write 49. And instead of writing b squared, we're going to write 576. So therefore, c squared is equal to 625. Squaring both sides, we can get the value of c, and c is equal to 25. Therefore, the values of a, b, and c are a equals 7, b equals 24, and c equals 25. Let's now have or identify the parts of the hyperbola using the learning that we gained. For instance, the given is x squared over 25 minus y squared over 11 equals 1. Again, we need to find or know or identify the orientation. So to find the orientation, again, we're going to take a look on the first term. The first term is x squared over 25, and x comes first before y. So therefore, the orientation is horizontal. Next, we need to find the center. Again, to find the center, we have HK. H yun yung kasama ni x, and K yun yung kasama ni y. As you can see, walang kasama si x at walang kasama si y. It implies that the center is located at the origin or at 0, 0. Next, we need to find the values of a, b, and c. So, we can have a squared, which is equal to 25. Why is it again 25? Because 25 is the denominator of the first term. And to find the b squared, we can have b squared is equal to 11. To get the value of a, we can get the square root of both sides. So a is equal to 5. To get the value of b, we need to get the square root of both sides. So b is equal to square root of 11. Now to find the value of c, we have c squared equals a squared plus b squared. Substituting all the values, instead of writing a squared, we're going to write 25. And instead of writing b squared, we're going to write 11. So it implies that c squared is equal to 36. To get the value of c, we need to get the square root of both sides, so c is equal to 6. Let's rewrite. So a is equal to 5, b equals square root of 11, and c equals 6. Now, we're going to use this in identifying parts of a hyperbola. Here are the pattern. The pattern that we use is center at the origin and orientation horizontally. So the pattern are this one. For vertices, for endpoints of conjugate axis, for foci, and then for the equations of the asymptotes. So we just simply substitute the values of a, which is equal to 5, b, which is equal to square root of 11, and c, which is equal to 6. So instead of writing a, we're going to write 5. And then instead of writing b, we write square root of 11. And instead of writing c, we write 6. So therefore, we locate the value or where the vertices, endpoints of conjugate axis, and foci located. After that, to know the equation of the asymptotes, we just simply substitute. Instead of writing b, we write square root of 11. And instead of writing a, we write 5. Since this is in simplified form, therefore, this is the equation of the asymptotes. So we have y equals positive negative square root of 11 over 5x. But if you want to use the graphing method, here is the illustration. The first thing that we can do is to plot the center. The center is located at the origin. And this is the center. So center is at 0, 0. Next, we can locate the vertices. In order for us to locate the vertices, we use the value of a, and your a is equal to 5. So, in order for you to locate the vertices, you're going to count 5 units, right and left of the center. Why is it right and left? Because the orientation of the hyperbola is horizontal. So, we have here the center, we have 1, 2, 3, 4, and then 5. On the other side, we have negative 1, negative 2, negative 3, negative 4, and negative 5. It implies that b sub 1 is located at 5, 0, while b sub 2 is located at negative 5, 0. Now, the next is we can locate the foci. To locate the foci, we have the value of c, which is equal to 6. Since we count left and right, 5 units left and right of the center, to locate the vertices, we will also count 6 units left and right of the center in order for us to locate the foci. So we have, this is the center, we have 1, 2, 3, 4, 5, and then 6. So we have 6, 0. And then on the other side, we have 1, 2, 3, 4, 5, and then 6. So here is the second focus, and it's located at negative 6, 0. The next is we're going to locate the endpoints of the conjugate axis. To locate the endpoints of the conjugate axis, we have the value of b, which is equal to square root of 11. So we need to transform this into decimal form, and this is approximately equal to 3.32. So now, we're going to count from the center, we're going to count 3.32 units upward and downward. So this is the center, so we have 1, 2, 3, 4. So 3.32 is in between of 3 and 4. So therefore, this is the endpoint of the conjugate axis. Next, negative 1, negative 2, negative 3, and negative 4. So therefore, it implies that the second endpoint is located here. Now, the next step is we're going to draw the auxiliary rectangle. After drawing the auxiliary rectangle, we're going to draw the asymptotes. To draw the asymptotes, we just simply connect we're going to draw a broken line from this point to this point, and then from this point to this point. After drawing the asymptotes, we're going to draw the hyperbola. And that's the graph of the equation of the hyperbola. To know the general form of the equation of a hyperbola, we have x squared over 25 minus y squared over 11 equals 1. So the first thing that we need to do, we need to multiply this by the LCD. Most of the time, the LCD is just only the two denominators. So we multiply 25 times 11. Now we're going to use the divide multiply process. So let's divide 25 times 11 into 25. It implies makakancel si 25, ang matitira 11. So 11 times x squared, we have 11x squared. Minus, we're going to divide this to this one, to this denominator. Matatanggal si 11, ang matitira 25. So times y squared, we have 25y squared. Equals, we're going to multiply 25 times 11 to 1. Since it is a whole number, it implies that 25 times 11 is equal to 275. After that, we're going to transpose 275 to the other sides. So it will be 11x squared minus 25y squared. Since we transpose positive 275, it will become negative. 275 is equal to 0. And this is the standard form of the equation of a hyperbola. Or the general form, the equation of a hyperbola. Let's try another example. This is the standard form of the equation of the hyperbola. Quantity y minus 5 squared over 100 minus quantity x plus 1 squared over 25 equals 1. The first thing that we need to do is to identify the orientation. Since y comes first before x, it implies that the orientation is vertical. After knowing the orientation, we're going to get the center or find the center. Since center is at HK, at yung H ay yung kasama ng X, eto si X, at ang kasama niya is 1, it implies that H is equal to negative 1 because we need to negate 1 and it will become negative 1. K, ito yung kasama ng Y. Ang kasama ng Y is negative 5. So, negating negative 5, it will become positive 5. So, the center is located at negative 1, 5. Next will be finding the values of A, B, and C. To get the values of A, B, and C, we're going to start getting the value of A squared. A squared is the first denominator of the equation. Since 100 is the first denominator, it implies that A squared is equal to 100. B squared is equal to 25. To find the value of A, we're going to square both sides. So A is equal to 10. And getting the square root of both sides to get the value of B, and B is equal to 5. To get the value of C squared, we're going to have C squared equals A squared plus B squared. Substituting all the values of A squared and B squared, it will become 100 plus 25. So C squared is equal to 125. Squaring both sides, we can get C is equal to 5 square root of 5. Why it becomes 5 square root of 5? Because if we're going to factor 125, it will become square root of 25 times 5. The square root of 25 is 5, so it will become 5 square root of 5. Now, let's rewrite the values of A, B, and C. A is equal to 10, B is equal to 5, and C is equal to 5 square root of 5. Since we already have the values of A, B, and C, and we already know the orientation and the center, we're going to have this one, the pattern. The pattern that we utilize is a pattern from center at HK and the orientation is vertical. So, therefore, here are the pattern. Here are the pattern for endpoints of conjugate axis. Here is the pattern for foci, and here is the pattern for equation of asymptotes. We just simply substitute all the values of A, which is equal to 10, B, which is equal to 5, and C, which is equal to 5 square root of 5. We also substitute the values of H and K. H is equal to -1, and K is equal to 5 since the center is located at -1, 5. Now, by substituting all the values of the given A, B, C, H, and K, we can get the coordinates of the vertices, endpoints of conjugate axis, foci, and the equation of the asymptotes. So for the equation of asymptotes, we just simply substitute A, which is equal to 10, and 5, which for letter B. Now, 10 divided by 5 is equal to 2. That's the reason why it will become y is equal to 5 plus minus 2 quantity x plus 1. Now, we're going to separate positive and negative. So, it will become y equals 5 plus 2 quantity x plus 1. And the other one will become y is equal to 5 minus 2 quantity x plus 1. Now, distributing 2 inside the parentheses will become 5 plus 2 times x is 2x, and 2 times 1 is 2. So therefore, y is equal to 2x plus 7. Because 5 and 2 are both constant term, therefore we can add 5 and 2. On the other hand, we're going to distribute -2 inside the parentheses, so it will become 5 minus 2x minus 2. Since 5 and -2 are both constant term, it implies that it will become y equals -2 plus 3. Now, if we're going to use graphing method, we're going to start plotting the center, which is located at -1, 5. After locating the center, we can locate the vertices. To locate the vertices, we're going to use the value of A, which is equal to 10. So we're going to count 10 units upward and 10 units downward. And here are the vertices. Next, we're going to locate the endpoints of conjugate axis. To locate the endpoints of the conjugate axis, we're going to use the value of B, which is equal to 5. So we're going to count 5 units right of the center and 5 units left of the center. And the endpoints of conjugate axis will be located here. After that, we can locate the foci. To locate the foci, we're going to use the value of C, which is equal to 5 square root of 5. Therefore, since there is radical, we need to transform this into decimal form, and it is approximately equal to 11.18. So it means that we're going to count 11.18 units upward and 11.18 units downward, and it will be located here. After locating the center, vertices, foci, and endpoints of conjugate axis, we can now draw the auxiliary rectangle. After drawing the auxiliary rectangle, we can now draw the asymptotes. And then, the last part will be drawing the hyperbola. And this is the graph of the standard form of the equation of a hyperbola. After that, we need to find the general form of the equation of a hyperbola. To find the general form of the equation of a hyperbola, we need to multiply this by its denominator, which are 25 and 100. 25 times 100. So we're going to divide 25 times 100 to 100, and it will become 25. So we're going to have 25 times y minus 5 quantity squared. Minus. We need to divide this here. So matatanggal si 25, ang matitira ay 100. So we have 100. X plus 1 quantity squared is equal to, so we need to multiply 25 by 100, and that is 2,500. Then, we need to simplify or expand quantity y minus 5 squared, quantity x plus 1 squared, and transpose 2,500 to the other side. So it will become, we're going to square the first term, which is y squared, square the last term, which is positive 25, and then to get the middle term, we just simply multiply 5 times y is 5y times 2 is equal to 10y. So therefore, we're going to have 10y and then copy the sign of the middle term, which is minus. Bring down minus 100. Let's square the first term, which is x. Square the last term, which is equal to 1. And then, what are we going to do? We're going to get the middle term. To get the middle term, we're going to multiply 1 times x, which is equal to x, times 2, the answer is 2x. And then copy the sign of the middle term, which is 2. And then transposing 2,500, it will become negative 2,500 equals 0. Next, we need to distribute the number 25 inside the parentheses and negative 100 inside the parentheses. So it will become 25 times y squared is equal to 25y squared. 25 times negative 10y is negative 250y. And 25 times 25 is 625. Then negative 100 times x squared, we have negative 100x squared. Negative 100 times 2x is negative 200x. And negative 100 times 1 is negative 100. And then bring down negative 2,500 equals 0. And then after that, we're going to simplify all the constant term. So we can simplify 625 minus 100 minus 2,500. So simplifying this, it will become 625 minus 100 minus 2,500. The answer is negative 1,975. So let's copy 25y squared minus 100x squared minus 250y minus 200x minus 1,975 equals 0. And this is the general form of the equation of the hyperbola. So that's all for today's discussion. I hope you've learned a lot for today's discussion. So again, happy math learning. So if you have, so kindly subscribe, like, and share our channel. And if you have topics or lesson na gusto nyo pong ituro namin using this channel, you can comment down the topic. Thank you very much and God bless everyone.